Hello and welcome back. In this lecture, I want to go through the environment of code blocks, just kind of show you the graphical user interface, how you can actually do some different things. We're going to be doing many demonstrations, so a lot of the detail will come along with those demonstrations. But I did want to show you some of the basics. After you successfully installed code blocks, you should see an icon on the desktop, but if not, you should see it in your program view on Windows. To execute the IDE, you just double click on the icon, which I'm going to go ahead and do. Once you do that, code blocks will start up. You may see a different version number here depending on what version you have. The first screen you'll see here is you'll see this code blocks home screen. You may have seen a tip screen as well. You can just disable those tips. But this is code blocks. This is the basic graphical user interface. What you should notice first is there's a menu bar at the top, and also above that you'll see the version number. But it has some of the basic menu options that come along with writing and executing code, and specifically for C. So you'll see a menu bar at the top with menu options, and then you'll see some toolbars below that. You'll see the management bar on the left-hand side and also the home screen on the right-hand side, and then at the bottom, again, another screen. So it's kind of divided between 3 or 4 screens here, at least divided by a menu bar, 2 toolbars, and then a screen on the left, middle, and bottom. And this is the typical environment you'll see when you write code. The top part here where my mouse is, you'll be your editor, and you'll start writing source code in here. On the left-hand side will be kind of a list of files in the project, how you manage your project. A project is a program, and it can have many different files. And then at the bottom, you'll typically have your output windows, and when you compile and stuff, you'll see output. That's at a high level. But let's go through some of the options first. Let's start right at the top with the menu bar. You'll see the file menu bar. What's important here is you can say new, and you can create some different source code templates, using templates. You can create an empty file, you can create a new class, a new project. I'm going to go through the process of creating a new project specifically in another lecture, which you'll need to do once you start writing code. But there is some other nice things in here where you can set build targets up. For the sakes of our class, you're not going to need to do a lot of this, but you should be aware that there are options here. There's also the open, where you can open up different source code files if you don't have a project, but we're going to be using projects. There's an import project that is useful if you want to convert a Microsoft Visual Studio project to a code blocks project. And then there's an export as well if you want to export your project to a different kind of format. And then you have your properties tab. Properties is important because it can set a lot of the different preferences. If you select properties, what you should see is the properties for your project come up. So from the next menu option would be edit. You'll see a lot of things in here. Basic, your editor, once you select, have some source code. You can do all sorts of things like copy and pasting, add specific toggle comments on and off. Again, a lot of this will be demonstrated when we go through actually editing source code. But you should go through this and try to see some of the different options. There's also options for refactoring code, if you change and modify your code, spelling corrections, and so forth. In the View tab, you can see a lot of different windows. You can change the way the windows are organized. There's different perspectives depending on maybe what language you're using in here. We'll be using C. You can usually just keep it as the default perspective. You can rearrange toolbars if you don't like how certain toolbars are there, but I usually just use everything as default. And then there's also certain view windows that are showing up that you can disable if you don't want them to show. But again, manager is usually basic, as well as editor and so forth, and the status bar. But if you want to use different windows, go ahead and play around and see what different windows you can open. Search is a basic menu option where you can look for different keywords in your files. It will basically search your project. So you can say find in files. There's also a shortcut for Control F, which is you typically want to use to find searching in files. But you can search all files. You can go to different files. Project will be your project menu option where you can create new files, add new files, remove files. You can see your project tree if you want. You can set arguments to your program. These will be command line arguments. And again, I'll show you how to do this when we go through demonstrations of command line argument programs. There's also the Properties tab, which is really important for setting preferences. Build, your build is your build option. This is your compiling option, how you compile. So once you created a project, and you have some source code, you can go to build and it will compile that file. It'll also link it. There's also a run option here where you can run. That would be executing the code. Clean is where you recompile and destroy all the object files in the executable. Debug is where I talked about how you find and fix your errors. There's a debug menu option. We're going to go through this in much more detail in another section. But there's all sorts of nice tools associated with debugging. Call stacks, adding breakpoints, stepping through your code to find errors. You don't have to worry about Fortran. Some of these other ones you don't really have to worry about. You can configure different tools. There's different plugins. When we need a plugin, I'll go through the process. Settings, you can set up your environment. You can mess around with this if you want. Where the general settings allow you to show a splash screen on startup. Again, most of this is intuitive and really user preference, what you like and what you don't like. I usually keep these, again, mainly as defaults. The view option, I keep as defaults as well. You want to make sure you have pretty big fonts, so I will change this to usually have bigger fonts. I usually use like a 16 font during demonstrations so that everything's really big. This is for the message logs, but you can also change the editor fonts if you want to see things bigger. There's other options for running static analyzer tools, setting up environment variables. I'm not going to go through all that, but you should see that they are there. CPP checks. Good different project settings or environment settings. Editor settings, these are things directly related to the editor. General settings for font size, tab sizes. You want to have tab sizes and spaces for 4. Again, mainly defaults for this. But if you have certain preferences that you want to change, go ahead and feel free. C++ editor settings. This will do a lot of the nice things for you by adding preprocessor code, indentation, highlighting things. You can go through this. The syntax highlighting, again, you can set up different indent options, different formatting. Source formatter is usually useful if you have a specific formatting option in mind. There's all sorts of different ones. If you've written code in Java before and you want formatting like that, it will give you examples. So if you want your brackets, excuse me, right after your if blocks, that's one way. I usually, again, just keep it as default. But if you're specific on different coding conventions, coding styles, I just use them. You can use Google. So again, it will do nice different formatting. And you could set that on style, brackets, indentation, formatting. This is pretty useful. Automatic formatting is important. Formatting is important because it makes your code more readable, especially when blocks are, you want to make sure your code is indented for blocks. You want to make sure that all beginning and ending brackets are also line up and so forth. So you want to make sure you format your code. Has options for code completion if you want to disable things. Again, I'm not going to go through everything, but you'll want to check some of this stuff out. Code editor is important. Compiler and debugger. Usually don't have to do much with this. For the compiler settings, you'll want to make sure that it's installed the compiler that came with the IDE. So usually the GNU GCC compiler, the MinGC compiler, or Cygwin compiler. Right? I'm using the GNU GCC compiler, but again, you might see the Min compiler here because that's what came with this IDE, or a Cygwin compiler. But you should have a compiler here. If you don't have a compiler set up here, then that means that you can't run and create any programs. You'll typically see an error when you install this IDE that says no compiler detected. If you install the one that I mentioned with the setup that automatically downloaded MinGW, that will come with that compiler and automatically detect that and install that. But you can play around with different compiler settings if you're more familiar, linker settings, but again, I would just keep this as default. And the debugger we'll talk about in our debugging section. Help for documentation's sake. If you go through some of the different toolbar options, you can do automatic things like saving. Here are some debugging or copying and pasting options. Play has to do with the debugger executing code. This is again related to debugger on that third toolbar by jumping through different statements. Editors, highlighting. Again, as we go through examples, we'll probably use some of these various things. This project management tab is important because this will identify your program and your list of files. So what you're going to see in the project management tab is the interface for the projects. the project view essentially. The editor, well, every time you click on a project or a file inside here, inside the project view, you'll see the editor show up on the right hand side. And this is where you can edit your source code and then build it and then see the output of the build at the bottom of the window. Typically there's build log, build messages. Again, if you're using a debugger, you would see that. You may want to resize this to make it bigger. We'll go through all this as well, but you want to be just somewhat familiar with it. These different windows and these different panes, if you will. There are different project templates when you create projects for different types. I didn't want to cover this too much. I just wanted to introduce it to you so that you understood some of the basics. But the best way to learn this is to play around it and also to go to the site and look at the documentation. And you can see all this in here. It's very intuitive. What we'll basically be doing is creating new projects, editing our source files, adding new source code, and then building, compiling, and then also using the debugger. So you're going to find this IDE is very intuitive, very user-friendly, very fast and compact, and has the basic requirements that we need to create and run C programs. It has the basic requirements of most integrated development environments. Thank you. Hello and welcome. In this lecture, I'd like to show you how you can create your first project using code blocks. So let's start up code blocks. And there's a nice, easy to use template to create a project. It's sort of referred to as like the Project Explorer or the Project Wizard. You also notice that there's a couple different ways you can create the project. If you've never created a project before, there may be a link on the home page where you can just say create a new project. But typically the way that you'll create a new project is you'll launch it through the File option, menu option. So go to File, you'll say New, and you'll say New Project. And remember that the reason that we're demonstrating how to create a new project is because the project represents the program. The program can contain many different source files. Right now, the first step in creating C programming is to create the project. So we're going to go to File, New, and we're going to say Project. And this is going to bring up the dialog for many different types of projects. Most of the projects that we're going to create in this class are going to be console applications. So that's what we're going to select right here. But you'll see there are many different categories. You can select an empty project. You can select different ones. But a console application is what we want to select for our purposes. So we select console application and we select Go, the Go button after that. Once we select the Go button, it's going to say, basically it's going to bring up this console application wizard. And it's going to say, welcome to the new console application wizard. It's going to guide you through creating a new console application. And you can skip this page if you don't want to see it on every creation. So you can just say next. And then it's going to ask you what kind of application you want to create. You want to select C. And then again, hit next. And then you want to give your project a title. Remember that you want to use meaningful names for all file names, even for projects. So the project represents the program. Since we're just going to be testing something, I'm just going to say project title is going to be test. You can create the project in any folder you want. If there's a particular specific environment on your PC that you want to put it, by default, I'm just going to leave it in downloads for now. But you will have to define that. It's going to create a file name for you, the CPB, but it's going to put the project in wherever you specified, and you want to hit the next button. After you hit the next button here, it's going to ask you what compiler you want to use. There better be something selected here. If you don't have a compiler that's auto-detected, you're not going to be able to create here. I have many compilers installed on my system. You should at the very least have your Minwin compiler or your Sigwin compiler. I just use a GNU compiler. But it should be the Minwin compiler you select here. I would just keep the other defaults as the same, creating both the debug configuration and the release configuration. And then you want to hit the finish option. And after you hit the finish option, your project will be created. You'll see basically on the left-hand pane side in your management view that if you select the projects tab, you'll see that there's now a new test project. And underneath there's a source folder. And the project template also automatically created a default file for me, which is main.c. We know it's a C source file because it has the C extension. We can double click that and then you'll see the editor come up. Now I have the editor especially large with text, probably a little bit too large, so I'm going to change that. And you can do that in your settings editing preference pile. I'm just going to change the font to be a little smaller. Maybe 18 would be good. I want to make sure you guys can see when I'm editing. So I think 18 is good. But this just created a simple main.c file, mainly a hello world application. It's a template that created some main code for you. And so your project is created. And as I mentioned, it will create some default code for you. This is going to look foreign to you right now. I'll explain this in another lecture. But this is the basics of creating a project. Once you've done creating a project, you can now actually start writing code and then executing it and running it as well. So other things you may want to do is, again, you want to analyze this project management window. You'll see the main.c file there. You can right-click that and you can remove it if you wanted to remove a file from a project. I'm going to show you how to add more files and projects, but if you right-click on sources, or if you say file, you can add new source files as well just by just going file, new, empty file, or if you want to select from a template. So here you would actually be able to select user or custom templates that would generate code for you. But you can see that under sources there can be many different files. And then eventually what you want to do is, in order to build it and run it, you're going to build it and run it from different things, but we haven't got there yet. In this lecture, I just wanted to show you how you can create a project. And that's basically how you do it. Thank you. Hello and welcome. In this lecture, I want to show you how to create and run your first C program. The purpose of this lecture is not to necessarily have you understand the code that you're running, but to introduce you to the compilation and the building, how to run your program and kind of what you encounter. So the first thing you need to do is you're going to need to bring up code blocks. So you want to double click on the icon here and bring up the IDE. Now we know from the past that the first thing we need to do before we can write a C program is we need to create a project. And we know how to do that from a previous lecture, so I'm going to go through that quickly. But you just go to File, New, and you say New Project. We're going to select the console application. We're going to keep the basics defaults. We're going to say C, Next. We're going to actually create a, just say sample app. This will be a sample application. It's going to be in our downloads directory and so forth. Hit Next. We're going to create, release, and debug, and say Finish. Now by default, this is going to create a file for us, main.c. I'm going to delete this because I want to show you how you can create your own single source file. So here I'm just going to say remove from the project. And again, the purpose of this lecture is to introduce you to the build and compilation phases. It's not necessarily important for you to understand the code in the lecture because we're going to go through that another time. So now that I have a project, I can right click on the project, or I can go up to File and I can say New File. So let's make sure we have our project selected and say File, New. We're going to just say Empty File. This is going to create a new empty file in our project. And we're going to add it. So we're just going to say yes. And what we're going to do is we're going to name this, and we're going to put it in the sample app. We're just going to name it test.c. And it's going to be empty, and we're going to create it for both debug and release. And so now you'll see that we have one source file, test.c, inside here. So we have an empty source file. I'm just going to put some example code in here. You don't need to understand the code. So we're just going to quickly copy and paste, or actually quickly type this in. And you'll see this code completion, which is nice for the IDE. But I'm just going to create a basic program with some example code, and we'll explain this later. So this would be the editing phase where we actually edit the source code. And so again, don't worry about this code, but we have a source file in here. And what we want to do once we've actually created our source file is you'll notice that there's some code in here, and that the name of the file has a C extension. So that's important. We have test.c. And if we want to now go to the next step, we want to compile it, we can go up to the build option. and we can say build. And what this is going to do is it's going to compile the program, test.c, and it's going to link it. So if we say build, you'll then see that there's output in the below log. Might be a little tough to see. But when I selected the build option, it actually tried to build the sample app project, which included one source file, test.c. And what this output window is showing on build.log is the command used to compile, which is ming32 gcc. It then used some compiler flags, you don't really worry about it. And it took as input test.c. And then from the input, the next thing it did was it linked right after it compiled the O file that was generated. But this will be the window where you can see any compiler errors or if it compiled successfully. You'll notice here that there are 0 arrows and 0 warnings. So I was able to compile successfully. So that compilation and linking worked fine. To run my program, all I have to do is go up to build and say run. And I could have done the build and run in one step if I wanted, but I wanted to just demonstrate that how you would do it. So now I would say run. When I run it, you're going to see that the program was actually run. And what happened in Windows is it brought up a separate window. It's basically the DOS prompt. And it ran the program with output. And what you'll see here before we look at the output is you'll see that the build.log actually ran another command, which is it basically executed the app that was generated from the code. And then when you double click on that, in Windows, it generates this DOS prompt. The output comes to the DOS prompt. So this is sort of, right here, this window here is the console. And this is where the output goes. You'll notice that the output of the program is, hi, my name is Jason. And then you say process return 0. That's just saying the program returned. Press any key to continue. But the output here means that the program ran with some output. And again, this is the console or the terminal. We can press any key to close it. And you will want to occasionally clear out your window too sometimes to just get rid of some of the, so it's easier to run. But you can see that build.log will show you. And you can build messages also can show you that there were no errors and so forth. There are different windows. So if you run, if you compile and it runs fine, you have no problems, then you're good to go. And this program didn't do much. It just output some data to the console. But what would happen if you ran and there were some errors? So for example, all C statements have to have a semicolon. Say I get rid of that semicolon and I save the file. And every time you edit a source code file, you always want to save it. You can do a Control-S, or you can go up to File, and you can say Save Project, or Save All Files, or right there, Save All Files. And now we have an error. So now when I try to build it, I go up to the Build menu and I say Build. You'll notice that if I go to the Build log, there's a big red highlight that says 1 error. And it's mainly because I forgot my semicolon. But this window here is the build log window that shows you that there's compilation errors. So you cannot run a program with a compilation error. We know that. Okay, so this is what you would see in errors, and running successfully is what you would see prior. So again, the purpose of this lecture is to show you how to build and run a program. The source code doesn't necessarily matter. So we were able to create a project. We were able to create a source file, test.c, and then we built it, which did the compiling and linking at the same time, and then we wanted to execute it, we just hit the run command. And if you have any errors when you build and compile, you'll get a red highlight and you'll have to go back and fix that error by adding the semicolon, hitting Control-S to save, and then going back to build, and if we build again, you'll see there's no errors in our build.log. So it built successfully, and then we can then run it again. And again, running it will bring up our window here and our output for the program. Okay, so a nice little demonstration to show you how you can build and run your first program. In our next lecture, I'm going to give you a challenge. I'm going to give you an assignment to do pretty much the same thing, except change the output a little. So you don't really need to understand the source code that much. You just want to change the output. Okay, I hope this was helpful. Thank you. Hello and welcome. Welcome to another exciting lecture, and in this lecture it's going to be our first challenge. So if you remember from previous lectures, I mentioned that I'm going to provide slides to you to help you learn the concepts. I'm also going to do demonstrations, which I've done both so far. But in order for you guys to learn the material, you have to have some kind of self-assessment. And so I'm going to be giving you guys challenges, essentially homework assignments where you can complete the homework assignments to see how well you're learning. And so in this lecture, this is going to be your first challenge. Very exciting. Our first challenge, our first assignment more or less. And so what I'd like to describe to you is what the challenge is. What are the requirements? And what this challenge is going to include is it's going to be writing your first program. So what we're going to do is you're going to write a C program that displays your first name as output. That's the requirements. That's what I want you to do. And so in order to complete this task and complete this challenge, you're going to need to do the following things. You're going to first have to create a project in CodeBlocks. And I've demonstrated how you can do that, so you should be able to do that. You're going to use the IDE to perform the tasks that you do in every C program. Edit, compile, and run, and then test your code. Right? So the first step is creating that project in CodeBlocks. You can use the lecture that I provided earlier if you need to go through those steps again. As part of creating a project, we know that it generates a file for you. I don't want that file generated for you because it's going to do all the work for you. So after you create the project, make sure you go into your project inside your project window, your management window, and make sure you delete the main.c file that was generated. You can right click on it and say remove. After you've created your project, the next step would be to create a new C source file. And we know that all C source files end in the .c extension. You should create the C source file in the project that you created, and you should name the source file test. Once you've created the source file, then you're going to have to edit it. You're going to have to actually put some code in there. The code that you put in there is not important. That's not what we're trying to learn in this phase. What you're trying to learn is how to create a program and how to compile it and run it. Writing the code doesn't matter right at this point. So what I want you to do is I want you to copy the source code that I've provided right here. And it looks a little weird, right? You see this pound, and then it says include, and there's an int, and it says main, and then there's these squiggly brackets and all this. None of that's really important. Copy and paste this. The line that is important is the printf, and that's the line you're going to need to modify to display your name. But I've started it for you. I said, hi, my name is. So copy and paste this code into your test.c file. After you've copied and pasted that code in this test.c file, you're going to need to modify the line so that when the program runs, it displays the right output. And so you're going to need to modify that printf line. Basically, just add your name where the dots are. And that will be part of editing the source code. After you successfully edit the source code, then you want to compile and link it. And this, again, was explained in another lecture, so this should be pretty straightforward. There's menu options to build. So you want to compile and link, and then you want to analyze the build output window. This step, again, is just going to your menu option and building. And what this will do is it will issue the GCC command to compile, and it will set the test.c files in an import, and it will also generate any object files, and then it will link all those object files to create a program. If you have any errors when you compile and link, you'll see them in the build window. That means you'll have to go back and edit your source code to fix those errors. Now, if you copy the source code exactly how it is on the slide, you'll be fine. One of the things you're going to notice with programming is the detail matters. Make sure you copy the source code exactly how it is. Everything matters. Okay, so if you're missing a semicolon or anything like that, it can cause your program not to compile. Now, if you were successful in compiling and linking the source code, then you want to run the program. You want to execute it. And again, this is just another menu option in the IDE in CodeBlocks. Once you run the program, it's gonna actually display a new console. It's going to display the DOS prompt, that little black window. And you need to analyze the output to confirm that it's correct. If it doesn't display your name, then you're going to have to repeat this process. You're going to have to go and edit the source code, recompile, which will link, and then run. And this is the process that you're always going to employ when creating a program. Editing, compiling, linking, and running. And then testing and debugging. Testing the code, making sure it does what it's supposed to do. And if it doesn't, fixing the errors. So this is your challenge. I'm going to provide a solution to this in the next lecture. But go ahead and do this on your own. Again, it's important to do it on your own so that you learn from it. All right, just watching the lecture, you may have missed some steps. If you go and do this on your own, it's going to be like the back of your hand the next time you need to write another program. So good luck, and I hope you guys succeed. Thank you. Hello and welcome back. In this lecture, I want to provide a solution to your first challenge. So this is very exciting. Remember that we had our first challenge, and our challenge was to write a C program that displays your first name as output. And so you're going to write and run your first C program. You're going to need to follow all the steps that you do when compiling and editing and so forth. So here's our solution. I'm going to bring up code blocks. We have to do that because that's the IDE that we use to edit and run our C programs, right? So when this comes up, because we're creating our first C program, we need to create a new project. So we're going to go to File, New, and we're going to say New Project. And I believe I told you to name the project. I don't think I told you to give a name to it. You can give it a name whatever you want. I'm going to name this project I'm going to name it Test. And this is going to create a project somewhere. And remember that we want to create our C source code file manually. And so first thing I want to do is I want to delete this auto-generated file. You don't always want to do this because it's useful that the code is generating, but for learning purposes, we want to delete it. So we're just going to say remove file from project. Now, according to the assignment requirements, instructions, we want to create a new source file called test.c. So we can highlight the project name, we can say file new, and we can say empty file, and we can just say yes for this dialog box that comes up, and we want to name the file test.c. So we're just going to say test.c, and we're going to say save. And we're going to then say OK. And you'll notice that now under your project, on your management pane in your projects tab, there's a new file called test.c. I then told you that you should just basically copy some source code that I provided for you, which is what I'm going to do now. This source code you don't need to fully understand yet. I'll explain some of it in the next lecture, some of the basics. But basically, it contains a basic example of a C program. There is something here on line 5. Line 5 is doing the main work. It's actually outputting data to the screen using a printf function. I gave you instructions that you should modify this to print your name. So here in the dots, you would actually type your name. I'm going to type Jason. You then have to make sure the file is saved. So I'm going to hit Control S, or I'm going to go up to File, and I'm going to say Save All Files. Once it's saved, you then want to follow the process of compilation, linking, and running. In order to compile this code, we have to go up to the build menu option and we have to say build. That will issue the compilation command. When we say that, you'll see, when we execute that, you'll see in the build.log window, you'll see that it compiled and it also linked. You know that it compiled because it uses -c, uses the test.c file as input, and then the -o is doing the linking. It's linking all those object files. And there were no errors, and that's what you want to see. If you write code, you don't want to see any errors in compilation. If there were an error there, you'd have to go back and you have to edit the source code. I also demonstrated that. Once the compilation and the linking is successful, you then want to run your program. So you go back up to build option and you say run, and then this will actually run your program. It will bring up the DOS prompt window, and you see the output here, which says, hi, my name is Jason. And that means the program was run correctly with the correct output. I analyzed the window and I verified that it's correct. And so now I'm done. If that was incorrect, I'd have to go back and edit my source file and I'd have to fix it. And that would be part of debugging, which we haven't talked about exactly yet, but everything worked successfully. So we completed our first challenge. I'm going to include this source code so that you can just download it and download the entire project and load it up inside of code blocks. Thank you. Hello and welcome. In this lecture, I want to basically highlight some of the concepts for a C program. I want to describe the structure of a C program. Now we're going to talk about the details of all the syntax and so forth in other lectures, but I want to describe at least some of the things you saw in your challenge, just some of the highlights. Again, we're going to go through other concepts in more detail, but the first thing I want to do is I want to bring up my project that we did for our challenge. So I'm just going to go to File, I'm going to say Open, and I'm going to open my test.cbp, which is my project file. And so you remember this. This looks familiar. I just wanted to show you a little bit about the structure of this code. We'll talk about include statements and so forth, but one of the important things to understand in this program right here is this is kind of the basic structure for all C programs. The first thing you should notice here is this code on line 3, which is called main. It says main there, and it has 2 parentheses. Those 2 parentheses are signifying that it's a function. Now, we don't know what a function is yet, but basically a function contains code inside of it. And so I want to describe to you that the main function is part of all C programs. It's the entry point to the program. This is what gets invoked when you run the program. Everything inside line 4 to line 7 will be executed. Okay, and so this main function is a special function in C that gets invoked when you execute the program. And you know it's a function because it has parentheses. And functions is just a way to organize your code. The things that you should notice here is on lines 4, you have a squiggly bracket, a left squiggly bracket, and on line 7, you have a right squiggly bracket. This defines the starting of the function, and then on line 7, the ending of the function. This is referred to as a block of code. So lines 5 and 6 is the block of code inside the function main. And again, I want to reiterate, main is a special function in C that gets invoked when you run the program. So there should be at least one main in all C programs, and only one main. Now, I'm going to show you how to structure the program with other functions, but this is a basic program, so it contains our main function, and this gets invoked. And then in lines 5 and 6, this is the body, this is the block of code for the function main. And you'll notice 4 and 7 start and end those functions. So what I'm trying to tell you here is blocks of codes and this idea of functions. These are all part of a structure of a C program. Other things to notice here is C programs are case sensitivity matters. So whether you use uppercase or lowercase, it's going to make a difference. So if I were to change this I in int to an uppercase I, it's not going to compile because that's an error. And when I said earlier that you have to pay attention to the details, I meant it. Every little detail in a program can cause a problem or cause an error. So case sensitivity matters, uppercase, lowercase. It makes a difference. The other important thing to notice here is, and the uppercase and lowercase, by the way, are distinct. It doesn't, and also here when we edit our source code, it doesn't matter where you start typing your line. You can type it at the beginning. You can put everything on the same line if you want, some of it. However, I will explain that it makes it easier to read if you do some kind of structure to it. But you can do that if you want to. The other thing that's important to note here that's not a specific concept is that all the statements are ending in a semicolon. So that's a syntax detail that you have to understand. Now lines 3 and 4 and line 1, those aren't statements of code. 3 is defining a function, 4 is specifying the start of the function, 1 is doing something different. It's including some library that you want to use in your code. But lines 5 and 6 have semicolons because those are statements. And we'll talk about statements and so forth, but you do want to recognize that a semicolon is also important. All right, and other concepts that I'm going to explain, I'll explain line 1, I'll explain functions in a much more detail, I'll explain why there's an int on line 3. But really what I wanted to point out here is the structure of blocks of code and functions. And this idea of the main function being the entry point of the C program. So this simple C program is, you're going to see very similar things in all programs. You're going to see that main routine, and you're going to see brackets for functions. And that's really how programs are going to be organized. Now, this function may call other functions. That's a whole other ballpark. But again, I want to emphasize here the idea of blocks of code inside functions, and also this idea of the main routine, and then the semicolons that end. Now, the other thing here that you'll notice is I did indent certain pieces of code. And we'll probably talk about this more when we talk about quality of code, but you want to make your code readable. And what readable code means is, if I were to just write my code like this, and I would have placed things on the same line, it makes it a lot harder to read, doesn't it? You see how that's a lot more difficult to follow? But when I add new lines, and I add indentation after each line of code, it makes it easier to read. You can easily identify that lines 5 and 6 are inside of a block of code because it has the brackets. And they're specifically inside of a function called main. So the use of indentation, spacing new lines in meaningful names, will make your code more readable. That's the other takeaway for your first program. I mentioned the main takeaways for the structure of a program, and readability is another important one. But this is just describing, again, the structure of a C program that you'll see in all C programs. In the next few lectures, we're going to talk about some of the basics of C. I'm going to describe to you this idea of the include statement, this concept of displaying output using a printf, the idea of returning data from the main. All these nice little concepts that are sort of really common for programs. They're not a specific category. They're really just fundamentals. And we'll be describing that in the next few lectures. Oh, and one other thing, just to give you a little heads up, this is going to be discussed in more detail, but other things that you may notice that sometimes students ask about is what's going on with this integer, right? And when we talk about functions, we'll talk about how you can return data from a function, but this basically just means you have to have a return. And this is saying that the main function is going to return a number. And what this usually represents is whether or not there was an error in the program. So when you return 0, it means that there was no error in the program. If you return an error code like 44, that might represent an error in the program. Right, but again, we'll talk about that in more functions, but be understanding of this keyword int. And you won't always see the int there. There are times when you'll see a void keyword there. And again, that's okay as well. That just means that the main function doesn't return any data. You might get a compiler warning for that, but typically you'll see int. But int just means it's returning something. Sometimes in the main, you'll see this keyword named void. And this just means that the main program doesn't accept any parameters or any data. Again, these are terms we use when we talk about functions. But when you see these things, don't worry about too much right now. They'll be explained when we talk about functions. But you do see void. Void is just another way to say no data. It's not required. It's pretty much the same with empty parentheses. Now, because the main is a keyword, you can't declare variables named main. That will give you an error, things like that. Just a couple gotchas that you want to be familiar with. Again, it's questions I get asked often. Why is there an int there for the main function? Why is sometimes I see a void? Why do we return data? Why do we return a 0? That's why, for error codes. Thank you.